Okay, we're going to continue. So we open this symbology pane for this layer, and we use the following guidelines to symbolize the layer. Symbology, we have a graduated symbols, and we're going to do the field is over 60. Start with right here, over 60 underscore food. Normalization none and method, we're going to use quantile, and that's the method we talk about here. So different methods, and go back here. Different methods, okay, right here. So the first one, the quantile, you divide it by for example, you have a 10, you divide it by 10, you have a 1 is each. So you divide it by the same amount of each sets. So it's the same amount of data. And then you will never have empty classes or kind of classes with too few or too many values. So it provides information about the shape of the distribution. And an equal interval is that such as you do the equal interval, like you do 2 and then 5 or 10. So, for example, you have the range that you want 2 to 3, 3 to 4, 4 to 5. So, and sometimes you will get data. For example, you have a lot of people from 8 to 10, so that you will have a lot of data concentrated on some parts. Okay. Manual, you decide which one you want to break. And the natural breaks, so clustering method that maximize the differences between classes and minimize differences within the classes. Generally, there are relatively large jump in value between class, so class interval are variable in width, and class ranges are specific to the individual dataset. That's difficult to compare for maps. So for example, this is the natural break. And for custom class, that you can just define on your own. Alright, so now we're back here. Quantile classes, we will do 5. And the scale color, graduated symbol, classes, minimize size, graduate, oh, not symbols, colors, graduate in colors. All right, then quantile, and I explain everything for you. You can still do deviation or something. The slides didn't mention about standard deviation, and we will do grayscale. Not this one. I think this one. Okay. All right. So now we have the data that match. Okay. Now we're going to click histogram. It's right here, histogram. To view the button, and now we can see the neighborhood with the highest quantile with 5 classes tend to cluster. The interval sizes generally increase in this case, so a geometric method is an alternative to the quantile method that we will test in so now the map clearly shows the neighborhood with a high number of households with person over 60 who receive food stamps and snaps. So I do want the food stamps. So I don't know how to get food stamps. So now we're going to change the symbology method for the color path map from quantile to geometric interval. So now the breakpoints become larger to provide more detail for long tail of the distribution. The breakpoints from the quantile method were, and those for the geometric method were this. Try define the interval method with an interval size of 2,500. Although perhaps not the best method for this skew data, this uniform attribution is easy to read, having nice numbers, multiple of 2,500 with equal intervals. We're going to change the method back to 5 quantiles and close. Actually, we could just add data and then do the same thing. Now I'm going back to chapter, and it will be chapter 2. Chapter 2, so let's see what data they have here. GeoDatabase 2. This one was the neighborhood, and I will try it, say, okay, this one we will try is the geometric interval. Okay, and then we will do symbology and graduated colors. Oh, no, graduated colors. Okay, and over 60 food, and this is non-geometric interval. And now we will do gray as well and going to close. Okay, so now I'm going to turn on and off, on and off, on and off, on and off. So we can see that the geometric, we will have less area of the color. 83, yeah, that's which one? 83, 830, 160, 20, 16, 20, and we have a 29, 29, 72, and 48, 31, and 115, 95. Then this one we have AA1, 2201. Their interval is a little different, and 41A1 and 714A and 11595. Alright, so now we're going to extrude a 3D color path map. Now we will learn much more about 3D data and scene later, perhaps chapter 11, but now we can easily convert 2D color path map into a 3D scene to better visualize the data. In particular, the map reader can get a better appreciation of extreme values relative to other values, which are not readily apparent by looking at only the color shading of color path map. So in 3D, features and layers are often physical features such as buildings, trees, topography, and so on, but we can display any numeric data as 3D. Here we will learn how to convert a 2D map to a 3D scene and display neighborhood polygon feature as 3D. So now we're back on View tab. So we will have a Convert here. So Convert automatically opens the category of 3D and 2D. So now it's in 3D. We'll just wait a little bit. So now in the Contents panel, we're going to drag over the 60 receiving food stamps directly under the 3D layer category. So 3D layer, we don't have anything. So going to drag this under here. Alright, so now we do have it in 3D. So next we will begin extruding neighborhoods polygon 3D using the numeric attributes as the extrusion height. So for the feature layer context tab, we're going to click appearance. So for appearance, there was a type extrusion here. That for the extrusion group, we click type and we will do base height and click base height, set the base of the extrude polygon 0. Where did it go? Okay, so field, okay. So next we will set extrusion height to attribute for the food field over 60 food and units US feet. That's fine. So the extrusion express, we did choose over 60 underscore food, and then feed, and the features and food stamp recipient data are now displayed in 3D. We're going to drag the middle button on the mouse to tilt the view. So okay, so you have to press the scroll thing, and now zoom better to the neighborhood. By zooming and scrolling and pan by dragging the map, we will learn more later. Okay, so now we will continue for 2.5, map using graduated and proportional point symbols. So Using the ArcGIS Pro, we can display polygon data using point symbols in the centroid of each polygon. So in this exercises, we will create a map showing the number of food pantries and soup kitchens in New York City neighborhoods as graduated size point symbols. The larger the symbol, the more food resources in each neighborhood. So we can also display data as proportional symbols that are similar to graduated symbols but represent values as unclassified symbols whose size is based on a specific value. And now what we're gonna do is we will save everything and we will open the exercise 5. There, it's a little slow. Now we're going to create a map of graduate symbol maps. It's right here. The map of here we will use 2 copies of the neighborhood's polygon layer. One copy displays household as a color path map. The other displays the number of facilities using graduated point symbols. We're going to use 2 copies of the same layer as a way to show 2 attributes of a polygon layer in the same map. So in the contents pane, which is right here, we're going to rename the neighborhoods. The first one as number of food banks and soup kitchen. So number of food banks and then soup kitchens. And then we will do the symbology. Graduated symbol, this time it's graduated symbols, and field will be food facility, and then method will be quantile, classes will be 5. Notice that the interval width is uniform too, except for the last class, so this attribute may be a good choice for the define interval method uniform attribute, and interval width of 5 is a good choice to include the maximum value of 25. Equal width intervals are the easiest to read and are of course best suited for uniform attributes, but this attribute is not essential. Another possible method is define interval, which allows you to easily read numbers such as 1, 2, or 5 times 10 to a power, for example 0.1, 1.0, and 10. We're going to change method to define interval. So now we need to resize the symbology pane to see the following options. So now we're going to click the template symbol circle and then we will do change the color. So the first one, we double check its graduated symbol and food facility, and nominalization is none. Facility 5 classes, minimum size is 4, maximum is 18. Template, we're going to change it into property, which is point as 4, which is fine, and we will do solar yellow and click apply and back in here, and it looks nice. It's still, the big is so big. The size, alright, so I forgot what size do we use. Interval size is 5. Interval size, define. Okay, now method define interval. So interval size will be 5. Okay, now it's a lot better. Okay, now we're going to close the symbology and zoom to full extent. Close it out and back to map and click extend. So now it looks nice. The finished map shows the number of food resources compared with the number of households with over age 60 receiving food stamps. The food pantries and soup kitchens appear concentrated in areas with poor population for the most part, as indicated by the map. And now we're going to do turn on the rename and second layer as under 18 receiving food stamps. So that's what I'm gonna do. uncheck this one, and I will say under